What's up, everybody? I need to talk to a physicist really bad. I've been working on this special relativity space-time calculator. It does a lot of things right and a few things wrong, and I need somebody to work through a little bit of math with me. The idea is this. I'm trying to make this simulator where I can set up any number of observers and give them a position and a velocity and a starting time, and then just launch it and watch as their clocks elapse. And then at any time, I should be able to switch frames of reference and view things from a different observer's perspective. Here's what I got so far. If I launch these rockets, start the simulation, they'll fly off towards their destination. When it gets there, it'll report the times. This sun is 4 light seconds away, and the rocket is traveling at 0.8 times the speed of light. So at the destination, its clock will read 5 seconds when the rocket arrives, but as time as experienced by a person on the rocket will only read 3 seconds. And that seems correct so far. Check out some other stuff that this simulation can do. I can switch perspectives. So if I go to, say, the sun, now the sun is my rest frame, which means that its x position is 0, it's in the middle, and everything else has been offset. And if I launch the simulation from here, cool. More interestingly, we can jump into the rocket's perspective. And when we do that, we're going to see all sorts of stuff. For example, this rocket's velocity is not going to be negative 1.6 times the speed of light. It's going to be 0.98 times the speed of light, because we're using the velocity addition equation correctly, and nothing can go faster than light. Also, length contraction has caused the destination to get closer. It's now 2.4 light seconds away instead of 4 light seconds away. The time at the destination is offset. It started its stopwatch some time ago because simultaneity of events is now broken. This rocket right here, which is the new rest frame, now has a velocity of 0, and the Earth and the destination now have a velocity of negative 0.8, the opposite of what they saw the rocket have. And when I launch this, the camera will track the rocket, and we'll see the times on the rocket and the destination. And this is where my program breaks down. I think everybody should agree that when the rocket reaches the destination, the rocket clock reaches 3 and the destination clock reads 5. Also, one thing that I would really like, the dream with this program, is to be able to switch frames of reference ad nauseum. So when I switch from the Earth to the rocket, and I see this length contraction happen, I should be able to switch from the rocket back to Earth and see things go back to the way they were. But instead, the length gets contracted further. Not what I wanted, but kind of what I expected based on the math that I'm using. So I need to talk to a physicist about exactly what these equations should be to get the kind of results that I would expect. I feel like I've sunk so much time into this program so far. If it never works, it'll be awful. Please help.